Right, this is compression, encryption, and hashing. So, types of compression. Representing audio, images, and video take up a lot of storage. So, for not to take up this any storage, people use a technique called compression to help reduce file size. So, lossless compression. None of the original data is lost. You can perfectly restore the file, and this is a lot better if you want to keep everything, but it only reduces the size moderately. Well, lossy would dramatically reduce it, but would also remove unnecessary details, so that means it wouldn't look exactly the same. So for which of these is lossy compression appropriate? Lossy is the one where you lose stuff, so that'd be text. Would it be video, messages, and executables, or audio? Images. So all the data is retained that is lossless, and data is sacrificed to get the best possible compression ratios, lossy. Run length encoding. One compression algorithm you need to know is REL. Run length encoding is a form of lossless compression that replaces repeating sequences of zeros and ones with more effective representations. So each repeating string will be replaced by a code that represents the character and the amount of times it was repeated. Oh yeah, I get it. So in images, adjacent pixels are likely to be similar colors but slightly different. So image compression algorithms often group these together and make them an average color. Then it would become a new image, which would be like groups and blocks of stuff, so it would use up a lot less data. So image compression algorithms often allow for same shape, not shape, color. Different color, but they are different color, pixels together and give them an average color. Well, they are semi-different colors. So what type of compression is run length encoding when pixels have been grouped together? Lossy, because you actually lose the color. So dictionary coding. Dictionary coding is used to store text in a lossless format. So the coder scans through the body of text. Each word is replaced by the binary number in the word in a dictionary. Each time it finds a new word which is not in its dictionary, it will add it to the dictionary and give a binary number. The word in the actual text is replaced with a binary number. So the benefit would be that it would take less bits to store 2-digit binary numbers than you store a 10-letter word. So no data would be lost, so the coding is lossless. But the problem is the encoder might not always build its own dictionary, so pre-used dictionaries would be used. So what type of number is text converted to using dictionary coding? So it's ones and zeros, so it's binary numbers. So what happens if a dictionary coder finds a word that's not in the dictionary? Well, binary values from other words are used? No. The word is assigned a binary value. Is it assigned a binary value? So each time it will add it. Yep. I thought it would be. So it takes a bit of time to do that. When compressing an executable file, well, it doesn't have to be, but lossless compression must be used. Lossless compression causes files size to reduce moderately. Image compression algorithms often group different color pixels together adjacent. Wow. So the dictionary shows the compression in the following text. The quick brown fox jumped over a lazy dog. So convert each word. So brown is 101 and fox is 011. Convert each word. Lazy is 110, dog is 111. And output recording 000, 001, 010, 011, 100, 101, 110, 111. Output off the code. Oh yeah, I do not want it in 4 bits. 3 4 1 2 3 4 1 2 3 4 0 1 0 0 0 1 0 1 0 1 1 0 0 1 1 1. What do you mean? The dictionary shows the compression of the following text. So convert each word: the, quick, brown, dog, fox. Convert each word. Outputs. What do you mean? Scans over. Each word is replaced by a new word. Each term finds a new word. The word in the actual text is replaced by binary numbers. Benefits would be it would take less bits to store 2-digit binary numbers and to use a 10-letter word. No data is lost. Encoder must be. So are you telling me to convert this into so that's 4, 5, 6, 7. So that's what you've told me to do. Dictionary shows the following compressed, blah blah blah, convert each word. Surely the output should be. There's no way is the quick. No, it can't be. Let's try this again and then we'll just look at the answer. Surely it's not adding them all up and then. That's literally what I did. That's literally word for word what I did. And you were like, nah. Right, this is some kind of juju in its head. So encryption, that's next. Where this is compression and encryption. Encryption, if sensitive data can be transferred, it's important that it is encrypted so third-party bad people don't get it. So encryption. Encrypting data is the process of scrambling data according to a specific algorithm so it can't be read by third parties. So when it gets to the actual recipient and or client, they can decode it and they can use it as they want to. Keys. Decryption keys. A lot of encryption depends on keys. There are a lot of keys and these are used to be able to decrypt. And you need to have this key to be able to decrypt it. Wireless communication. This is especially important for wireless communication because packets are being sent all across the network and can easily be retrieved. It's especially important to encrypt a personal network because it has a high personal network? A wireless network. Yeah, Wi-Fi. So which do we know as the wireless? So symmetric and asymmetric encryption. The use of encryption is vital to protect our personal information. One type of encryption is symmetric encryption. Symmetric encryption, or private key encryption, is used to encrypt data for transmission. A private key is used to convert plain text into ciphertext. So ciphers are basically, like say, an A becomes an F, so it changes it a certain amount. This ciphertext and private key are then transferred to another location or person. The key is then used to decrypt the cipher back into plain text. Security. Using a single key to encrypt or decrypt text proposes a massive flaw in security, as anyone with the key can decrypt the cipher. As with passwords, the longer the encryption key, the less likely it is to be comprised by brute force. Brute force is basically when they try every single combination until they get the answer. Asymmetric encryption. Asymmetric or public key encryption is a lot stronger because it uses two keys, a public and a private. The public key is given to anyone who wishes to send you encrypted data. The public key can only be used to encrypt information but not decrypt it. The private key is then used to decrypt the data, but only you have the key. Public and private keys. So the public and private key is related to one another through mathematical operations. This is different to the symmetric where both have the same private key. How many keys are used to perform symmetric? One, and both have it. Simple. So hashing. Hashing can be used for both protecting data and comparing files. Hashing is the process of taking an input, performing some type of calculation on the input, then outputting a fixed value of a fixed size. This is called a hash. The hash function has no inverse. This means hashing is extremely secure because you can't reverse a hash to get back to the original data. So hashing can be used to store passwords. When a user creates a password for an account, it is put through a hashing function and stored as the encrypted password. A password entered by a user to to gain access to an account will be put through the same hashing function and compared to the stored password. No one can know your actual password by looking at the database. Digital signatures. Hashing can be used to add digital signatures to files. The hash output value can be encrypted with a private key and sent to someone else, and they know the matching public key to decrypt. This way, it has only come from that specific person. Why does a hashing person need to be non-invertible to ensure the security? A non-invertible function is a person that has no key, code, reverse. A non-invertible function is a function that has no inverse, which I've already said. This means the original hash value cannot be obtained to find the original file or the original data. If someone were to obtain the hash values, the original data remains encrypted, secret, encrypted, anything. The hash output value can be encrypted with it's not an encryption key. I'm pretty sure it's not an encryption key. Hash. It's a something key though. It put through a hash password. Password is given. Hash function. Encryption key. The hash output value can be encrypted with a something key, hash key, and sent to someone else, and they can use the matching something key to decrypt. Hashing digital signatures, the hash output value, private key, and sent to everyone else to matching public key to decrypt. Private, and then public. So, the something, the encryption key, the longer the encryption key, the less likely it is to be comprised by brute force, and so the more secure the encryption. So what is the output of a hashing function known as? The output of a hashing function would be known as the it would be known as a hash. It would be known as a hash. Wow. The output of a hashing function is known as a hash. So encryption is the process of scrambling data according to specific regulations, specific protocols, specific instructions. I sweat. The answer is all of them, but encryption is, let's hear what your definition is. According to specific algorithms. So is algorithms and instructions different? Algorithms. Wow. Who would have thought it? Is the following statement true or false? Anyone with a private key can decrypt the ciphertext generated by systematic. True. They can do it systematic, not with the other two though. So that is encryption and